So now we have a different kind of discontinuity. This is called an infinite discontinuity. And why? It's because this point continues infinitely downwards, and this point continues infinitely upwards. And it never touches the value x equals 4. So how do you find the limit of this? Well, same thing. I'm going to find the limit from the left and the right, and then we're going to see if the limit in the middle exists. Now we're going to be finding the discontinuity of an infinite discontinuity. So this is infinitely discontinuous because this continues downwards forever, this continues upwards forever, and it never touches the value 4. So I'm going to be finding the limit from the left and right, and then we're going to be seeing if the limit at 4 exists. So limit of the limit of g of x as x approaches 4 from the negative side, so from the left side. So I'll put that there, up there to indicate from the left side. And that would be does not exist because it goes infinitely downwards. You can't find a limit because if you look at, like, for example, 3.9, it might be negative 29. And then if you look at 3.99 as you get closer to 4, and then it might be negative 58. And it'll just keep on increasing exponentially. And you can't find a limit like that. So it will be the same thing for limits of g of x as x approaches 4 from the positive side. So this approaches from positive side coming here. It again will be does not exist. So since both of these do not exist, well, you just have to look at one of them. So if one of them does not exist, then the limit of g of x at x equals 4 does not exist. So now I'm going to be going over if the point at x equals 4 is continuous or not. And we're going to be using the 3 steps. So the first step is to find g of 4. Why 4? Because it's the point we're trying to find, is it continuous or is it discontinuous? So g of 4, well, is there continuity at that point? So g of 4 does not exist because there's no point at g of 4. This infinitely gets closer but never touches. Now the second step is what I did last time, just finding limits of g of x as x approaches 4 from the left side and the right side, and I got does not exist for both of those. So let me quickly just write those down, what we found just a few moments ago. And now we move on to step 3. And step 3 is from step 2, we found that both of these limits do not exist. So that means the limit not going from the left to 4 or the right to 4, but the limit at g of x is at 4 is not equal to, because this does not exist, is not equal to g of 4, which also does not exist. So overall, there is no continuity at x equals 4 for getting the limit at x equals 4. So we need to put points that get closer and closer to 4. So 3.99 and then 4.01. So closer from the left and closest from the right. So at 3.9, this would be really, really close. And that'd be at, let's just say, negative 9. But then when you get even closer, it will be exponentially higher. So then it'd be something absurd, like negative 988. It just get increasingly higher. Like even if I were to do 3.999, it'd be probably in the 100,000s. It'd be way too far. So the limit does not exist from the left coming to the right. So it does not exist from the negative side going to 4. Same thing from the right side, because this also gets infinitely higher and higher. So it'd be something very absurd, like positive 988, and then 9. So it just jumps really further, like really far.